Martin therefore proposed the first open ocean experimentation in history to support the iron hypothesis. He made plans to add small traces of iron into the oceans of the high nutrient, low chlorophyll zones to test if phytoplankton growth and productivity would increase. This field of study was so intriguing to the oceanographic community that the first open ocean iron fertilization experiment was allowed and conducted near the Galapagos Islands in 1993. Unfortunately, Dr. Martin passed away 3 months before the cruise set sail, and he would never get to see the historic testing of his hypothesis. The first open ocean iron fertilization experiment was called Iron X1. The findings of Iron X1 supported the iron hypothesis because a bloom of phytoplankton was spurred from the addition of iron and had increased chlorophyll concentrations. Since Iron X1, there have been 12 additional studies, 12 additional small-scale open ocean iron fertilization experiments that have unequivocally supported the iron hypothesis. The experiments fertilize about 100 square kilometers of ocean and have shown that the addition of iron increases phytoplankton populations. The primary studies were meant to explain how the world works, but recent studies within the last 5 years have started to gear towards ocean iron fertilization's effectiveness to sequester carbon and mitigate climate change. And this is a picture of a sediment trap that's used to take in organic carbon that's floating to the deeper seas to see how much carbon export is actually occurring. So in order for commercial ocean iron fertilization to begin generating sellable carbon offsets, the scale of the projects would have to increase drastically to thousands of square kilometers. But there are a variety of concerns and uncertainties about the impacts of larger scale ocean iron fertilization. Phytoplankton blooms have been shown to increase or decrease levels of dimethylsulfonioproportionate that reduces to dimethyl sulfide. Dimethyl sulfide serves as a cloud condensation nuclei that increases cloud formation and could actually create a cooling effect for the Earth's climate. The growth of some diatom species of phytoplankton increases levels of nitrous oxide and methane that are also highly effective greenhouse gases. Another major concern is that large phytoplankton blooms will alter nutrient cycling of nitrogen and phosphorus into other areas of the ocean and possibly limit the primary production of those regions. Another potential ill effect is the production of a biotoxin called domoic acid. This is one of the scariest ones, by some species of diatoms. Domoic acid can bioaccumulate up the food chain and cause mortalities in marine mammals and maybe humans. Creating the large-scale phytoplankton blooms will have dynamic effects on the food web. Changes in population sizes of many different species will occur. This could influence an increase in non-beneficial species such as jellyfish, but the changes could also increase fish stocks, boosting a natural resource that has been dwindling in recent years to help feed an ever-growing human population. The significant ill effects to ecosystems and otherwise have not been observed during the short, small-scale ocean iron fertilization experiments, and many of the impacts are shrouded with speculation. The premier company that is proposing to develop commercial ocean iron fertilization is called Climos Incorporated, and it has created a code of conduct for their activities that revolves around the concerns about ocean iron fertilization. I had the opportunity to conduct phone interviews with 3 of the top executives at Climos, including their CEO, Dan Whaley, Vice President Bill Kors, and Director of Marketing Strategy, Kevin Wildman. They gave me insight into their business plan. Climos plans to quantify tons of carbon dioxide that are sequestered in the oceans during ocean iron fertilization projects, and sell those tons as carbon offsets within the voluntary carbon trading markets. The carbon offsets, called Climosets, would guarantee 100% that every ton of carbon is sequestered away from the atmosphere for a period of time for at least 100 years. But there are several steps that must be taken before Climosets will ever be produced. Climos recently received a $3.5 million investment from Bramer Energy Ventures that they plan to put towards conducting an environmental impact analysis on ocean iron fertilization by a third party. This type of analysis has never been done before for a climate mitigation technology and will be the largest environmental analysis in history. The analysis involves a series of science workshops and reviewing previous research to evaluate the sensitivities of the affected marine environment. The analysis will be used to further discussions with governmental agencies, environmental organizations, and the scientific community. It will also be used to apply for a permit to conduct their first ocean fertilization demonstration. They need to attain a permit from a signatory to the International Maritime Organization, a governing body for the open seas, in order to conduct their demonstration. Climos was planning to conduct a model demonstration in the Southern Ocean in late 2009. So this is going to be coming up really soon. During which a team of third-party professional scientists will fertilize a patch of 175 square kilometers of water with 1,200 tons of iron over an 8-day period. They will monitor the patch for a 45-day period, targeting research on verifying and quantifying the amounts of carbon that is exported and sequestered within the oceans. Another goal of the cruise is to identify ways that will improve the efficiency of OIF projects at sequestering carbon. And it's possible that they may be able to patent the iron mixtures that they're adding so that other companies can't use this. Validation of the carbon sequestered will be conducted by a third-party verifier to make sure falsification of credits is not occurring. If Climos can legally continue conducting ocean iron fertilization after this initial experiment, they mean to gradually scale up the projects and produce more carbon offsets. They wish to provide 10% of the total carbon offsets in the voluntary carbon markets. This would make Climos a $300 million business in 5 years. But they have the primary goal of entering into regulated trading markets where the prices for offsets are much higher. If this happens, they can sell Climos sets at much higher prices, turning them into a multi-billion-dollar industry. The team at Climos is enthusiastic and passionate about developing their business. When I asked CEO Dan Whaley what the end game was for Climos, he candidly replied, to remove as much carbon dioxide out of the atmosphere as possible. The international studies on iron fertilization have done a lot to increase understanding of iron's role in phytoplankton growth and productivity. But larger and longer studies are needed to better understand the other impacts of ocean iron fertilization. The private and public sector must proceed with caution in this area and create carefully designed research that quantifies environmental impact. By increasing the scope of these projects incrementally, we can find if ocean iron fertilization is a safe and effective tool to mitigate climate change. International regulations should be adapted to limit the size and scope of ocean iron fertilization projects at a certain point, as well as holding parties liable for any detrimental impacts that they may have. If the effects are found to be severe, then I suggest that the international community should bolster legislation banning large-scale ocean iron fertilization completely. Ocean iron fertilization has good potential as a carbon sequestration technique, and it may be able to take several hundred million tons or more of carbon dioxide out of the atmosphere. This would make it serve as one stabilization wedge for mitigating climate change, but many more are needed to solve the problem. Ocean iron fertilization is a controversial topic. Many of the arguments for and against commercial ocean iron fertilization are actually not based in science, but based in differing personal ideologies. Skeptics see ocean iron fertilization as an engineering project geared towards making a profit and altering marine ecosystems for human benefit. Proponents of ocean iron fertilization see its potential to enhance biological processes to make less efficient areas of the ocean more rapidly reduce carbon dioxide from the atmosphere than would be occurring naturally. This topic is very intriguing, and I believe more opinions should be developed on the issue. Hopefully, I have provided you with some insight that you can share with others, as I know I have because I've submitted my project to the top executives at Climos and other leaders in this field. Ocean iron fertilization has great potential to remove carbon dioxide from the atmosphere, but it will not serve as a long-term solution unless we reduce the source of emissions. The science of this project made me realize the true interconnectedness of the natural world. Every individual is responsible for their impact on climate change, and almost every decision that we make alters the climate in some way. Having said that, I realized how much energy I was using during the seemingly endless amount of hours I spent researching and writing this project. So I bought voluntary carbon offsets in order to make this project carbon neutral. So I will leave you with the philosophical teachings of Michael Jackson, who said, if you want to make the world a better place, take a look at yourself and make that change. Make that change.
No, I might have got